recording. Okay, I start the recording a half hour later, but not because I'm late or anyone late. I forgot to start, and I talk about the requirements of this course, and I repeated what we discussed yesterday during the lecture. And now we are starting solving problems, and this recording is perfectly useless actually, because you will not see what I'm writing. And also this is useless because this is in Hungarian, but don't worry, I will it's here. Okay, let's continue with this. We started with the B. Okay, so okay, so the simplest way, Cyrus rules. That's simple, great. This was the Cyrus rules, but there is another way. Dark side. Oh no, that's something else. Okay, so with appropriate transformation, you can do this Gauss elimination. Now I will not forget. I change the rows. Here is the sign. Okay? And then I add, not add, actually add, but not that way. The first row, 5 times the first row to the second. That's the same. So 5 times, that's minus, this is minus 10, so it's minus 14, and it's upper triangular form. This is the upper triangular form, and I just multiply this, and it's minus minus 14. That means 14.
So what we just did, we just went minus 1, right? From the second row.
It's minus 14. What I did, that's the Gauss elimination. In the Gauss elimination, I just show you because then it's easier. We can do some operation. The purpose is to transform everything to this upper triangular form. Upper triangular form is when all elements below the main diagonal are 0. Then you just calculate the elements in the diagonal and you got the determinant. If you calculate quickly, then it's easy. You calculate this with Sarus rule, calculate this, that's 0, so that's okay. Here I changed the rows, the first row and the second, so the sign changed according to that one. Then I don't forget right now. And then this is 1. I want to eliminate this row, so I subtract 5 times this row, the first row, from the second row. This is all over. This is the second stuff. Yes, and then we are ready. It's okay. Okay. Great. More coffee, and then I will not make mistakes. Let's do it again. We had done the B actually. When you think something is weird, imagine that we are calculating small matrices. And even you, that's okay, the physicist, and even in chemistry, perhaps you will need to calculate large matrices, very large matrices. Okay, let's start with the Sarus rules. Then 0 times minus 2 plus that 0, of course. I'm happy with this. I have 2, 0 minus well, okay, it's not the nicest stuff, but I don't have so many places, so it's 1 or 6. This was the Sarus rules, and if I am right, yes, it's good. This was the solution with Lazarus rules. It could be Sarim or Serim or something, I don't know the pronunciation. Okay, let's do the same with Gauss elimination. I had done this yesterday. First step. Now we can start the Gauss elimination for a very simple reason. This is 0. And this is not the desired format. So I change the rows. Yes, I change the rows. Then the determinant sign changes. Okay, now I can start the Gauss elimination. First, I subtract the first row from the third row. Zero, great. That's 2, and that's -1. Yes. Great. Now I have to eliminate this. And what I will do is I add to the third row the half of the second row. It means it's the same, this is the same, and this is half, -2, 2, 0. I add half, that's 2. Okay? And then this is -1. It's 8 again. I am familiar with this, and you too. And in theory, all of you are familiar with this. So this was a second solution with Gauss elimination. Yes?
Will we be tested on Gaussian elimination or the Saros method? Will our exams have the Gaussian elimination or the Saros method on the exams?
Sorry, what is the question?
On the tests, will we have the Gaussian elimination and the Saros method? Will we have
usually I will not restrict your methods. You can do whatever you want, and you can choose what methods you want.
Okay.
You can use brute force and eliminate, calculate with Laplace expansion for the first row of a big matrix, like I showed yesterday. There were zeros in the second row, and you can start. So it's up to you. These are just methods.
So you mentioned we don't have to calculate all all this stuff like this, we can use any kind of like calculator or a computer to calculate the matters.
Yes, this is a repeat actually.
Or the questions will be like this because we have already solved these kind of questions elementary in algebra.
Yes, you do, but this is a repeat.
Ah.
And actually, I can give you some theoretical questions. So, as I showed you yesterday, you have so the third question. Wow! It was no problem. It was a long time to write. So what is the value of this determinant?
Should be 0.
Yes, of course. I gave you such a large matrix with such a silly numbers that not to calculate this determinant. I gave this at the exam. For example, first I gave it in 5 times 5 matrix and someone calculated it. Then I gave a bigger. Still someone tried to calculate this. So finally I gave something unlimited stuff with the same columns, and then they start to think, okay, how can I fix it? So that's the theory. You do not need to calculate.
Exactly.
For me, I not really know what I will put in the test, but I will figure out. And also in the exercises.
And you will provide us with a sample test of questions before.
Of course, the others just asked me to do this test. Practice exercise. Okay. B, great. Here, which is important stuff, is the elimination. Okay, the next one. Haha, that's interesting. C, yes. Okay, so you cannot use Salus method here. And you can start with Laplace expansion. First row or the last. It's better. Because there are 2 0, you also can choose these columns But then you have to multiply stuff with 2 and 6, and multiplying minus 1 and 2 is easier. So, that's minus 1 times 3, 2, minus 1, minus 3, 2, 3, 6, 1. So we delete this and this. Okay, and, oh wait, perhaps I'm wrong. Plus, minus, minus. So this is minus 1, but because of the, this, I call this chessboard rule, but in English I think it's something different. This should be plus, so minus. Okay, the next one, that's 2 and 4, that's plus, and remain plus. And then it's okay, so I hope I didn't make a mistake. Yes, no, great. And we can continue this. This is quite simple. That's 0 plus 12 plus minus 1 minus 3 plus 3 and 6, that's 18. Okay, then minus 0 minus minus 6, that's plus 6, minus 3 times 2 times 6. Oh, how much is it? It's big.
36.
36, yes. Plus that's 0, 2 minus, that's minus 4, minus plus, okay, minus, that's 0, minus, that's plus 4, and minus 1, that's minus. It's all together, it's 30, interesting, 36, that's 0, plus 8, 12, 0. So that's a big 0. Interesting? Yeah, it's 0. That was not the brute force, but the
Professor, when the determinant becomes 0, we can say that those vectors are about the cardinal?
Yeah, we can say such a things, but not now, next time.
Oh, okay.
Mm. Yes. Okay, that was good. Sorry. That was a mug of espresso, actually. Well, this was the Laplace expansion. Okay.
Are you allowed to take a picture?
I have
Take
taken.
Sure, I didn't see.
Actually, camera on there would be more useful, but
This is fine.
I had no time to. I mean a full camera when I explain, and you can see what I show on the table and what I do. But well,
No, it is more than enough that what you are doing, to be honest.
sorry.
It is more than enough that what you are doing.
Okay,
for us.
thank you. Okay.
But usually it's our duty, it should be our duty to take notes and prepare.
Yeah, you are doing notes. Just it's my past. So at the Elfish University, the lectures were not so good. They don't interested in whether we understand something or not. I was physicist, that not physics teacher, physicist. That's the elite commando. And if you do not understand anything in the lecture, then they said your abilities are not enough to be a physicist. So that was the way, and I hated this, and that's why I record everything and do everything, because most of my student time was to go to a library and find these methods, because it was not properly addressed during the talks. I told you the three criteria of a wrong lecture: writing the formula and do not explain it, cover it, and then erase it quickly. That's a joke. It was a joke by the head of the Department of Astronomy, but that was guideline most of the physicists.
Yeah.
I'm a physicist, not physicians.
Yeah.
Okay, so next one. Actually, this is one expected thing to make you to develop an ability to choose the appropriate method. Sometimes the Sarus rules, sometimes the Gauss elimination is better. And this everything, this elemental linear algebra and linear algebra is in close relation with computational physics, numerical analysis.
Yeah.
It's actually we are doing something that's an algorithm.
I mean, literally, it includes everything in quantum mechanics, in a lot of Newtonian mechanics as well. We use it in general relativity. We use a lot of tensors.
Yes, yes.
So it's quite important.
Yeah, this is so-called tensor algebra. There will be PhD defense very soon about general relativity. I will send you invitation if you want.
I will definitely join. It's my
One student working at the Wigner, my second workplace, did his PhD here. And his supervisor was my roommate in the dormitory. And he died when he was 55 years old because of brain cancer. It was in March, so the burial ceremony in March, and it was quite sad. Okay, so I am here and start the Gauss elimination. That will be longer than this Laplace expansion right now. Let's start. Okay, so what I will do, lot of things. First, I appoint the first row, that's fine to me. And then I add the twice of the first row to the second. I add the first row to the third, and I also add the first row to the fourth. This is, so it's easy to make mistake. Okay, let's start with this. That's 0. Twice the first row, it's 3, it's 4, and that's 0. Great. Then that's 0. Then that's 6, that's 8, 0. 0, 5, 2. Okay. Let's do it again. Okay, okay. Okay. Okay, okay. And okay. So I did this, and we are ready for the first column. Oh yeah. Then I will continue, and I add the third row, the -2. Oh, you cannot see.
Yeah.
That's criteria 2, M2. You know, standing.
The thing is that why don't we make the diagonal to 0, then diagonal to 0, then it's going to be absolutely 0. Because we can do it. Right?
Yeah, but I don't. I want to eliminate these numbers and this number.
Okay.
It's upper triangular that I want to do.
That's all.
Also, there are methods for diagonalization, and they are important because of I explained just right now. -2 and that will be horrible. Okay.
It comes simply becomes zero because one drop becomes zero literally.
Oh, that's interesting. Thank you. That's interesting. And honestly, we could have stopped it here. Let's see the original.
I also did the Gauss elimination, and the bottom row is all zero, so the result will also be zero.
Okay, I understand, but I'm looking for something else. Okay, we do not need to do the Gauss elimination, just it has no sign right now. So if I do this, that's zero. Everything is zero. And here, it means that's zero. In this moment, it says it's zero. But I can finish this operation.
Wow.
Because there are different ways to explain this. Okay, it's. Oh no.
Is it negative 10 thirds?
Just a moment, it's yes. And okay, there are different ways to terminate this, but this is zero, so this is zero, but also in the main diagonal there will be, finally if we do this, there is zero, but it doesn't matter. This is zero, so this is zero. I just looked there whether there was any sign of this, but there isn't.
Yeah, that's why I thought that it should be linearly dependent somehow. And now it clearly shows that how they are dependent to each other. As each component becomes to zero.
Okay, so that was interesting. Yeah. Okay, so the question of this, what is this? The value of this determinant. Actually, in elementary in algebra, I never gave such a task. There I have some guideline. There was also someone who gave the practice and provided me previous tests, and never had this. But it's good, for example, in an exam. So we should determine this determinant. We have to calculate the determinant of this.
It will record only one step.
Sorry. What was the question?
Oh no, nothing good. No.
So we have to calculate this determinant very quickly. It's too big. If you
Did we subtract?
subtract the first row from each row, then that's okay, and everywhere.
Oh no, I guess.
Yes.
Why don't we multiply -1 to the second row and add it to the first row? Then all the diagonals will become 0. That's
No. Okay. Do you suggest to add the what?
Second row multiplied by -1. We multiply -1 by the second row and add it to the first one.
Yeah, you can do the Gauss elimination. Okay, we will do this. But now I suggest to subtract the first line from all other lines. And then everywhere you will be 0, except in the main diagonal. It means that because this is 1 and the other is -1. This is one way to fix it. You suggested something else. Let's meditate about this. You subtract the first line from all of them, then I will get Okay, let's do this. Then that's 0, 0. Okay, 0. That's great.
No. What I mean was that minus the first row, I mean, multiply the second row by minus 1. Okay?
Yes.
And then add it to the first one.
Well,
It will make all the diagonals to the 0. We don't care, I mean, what will the value of the first row, but if all the diagonals are 0, it's 0.
okay, but what do you get if you do this? Okay, you multiply this minus 1. Okay, then it's everything is 0, and that's 1.
Yeah.
Okay, great. And then?
Then, if theoretically we know that if the diagonals are 0, the determinants will come up to be 0, right?
But this is not 0.
Which one?
The result of this is not 0.
Really?
The determinant is not 0. Yes, there are some contradiction.
Why?
I will answer you soon. Hmm? So you suggest something else.
And maybe I'm wrong. but
No, I have to understand what you're suggesting. Okay, so you add that 1, 2. So this is 0. This is 1. And then everything is 0.
Yeah. And all the diagonals become 0. All the matrix.
This is not true. This is true if you calculate the determinant as the multiplication of the element of the main diagonal when the matrix is diagonal or upper triangular.
Yeah, okay.
So in this case, it's not true. Do you understand what we are talking about?
Yes, yes.
Okay, okay, great. So then that's the solution here.
Yeah. Makes sense, yeah.
But thank you.
So, Professor, what is an and is the number of elements in this matrix?
Sorry?
What is, I mean, the answer is minus 1 to the power n minus 1.
N minus 1, yes.
N minus 1. So
That's the determinant.
okay, the number of the elements, right?
Sorry?
Okay, and is the number of the
Yes, the rows and the columns. Okay. We had example, if we change the rows or columns of a determinant, then the value of the determinant changes its sign. That's okay. If two columns are the same, then the determinant is 0. That's also great. This is the third row. If you multiply one row with a number, that's 2, that was 2, then the determinant value is also twice. It's not a deduction, but at least interesting. Okay, and C. Is 2, 1, 3, 6, and it's so here this row is the sum of the second row of the A and the B, and also the determinant is the determinant of the A and B. D. Yeah, try not to.
You should place it somewhere else.
Oh, I sometimes sit down on it.
Ah,
Well, you know, it's a very dangerous profession. Yeah. Okay, here, if you add this, I multiplied with 2. I multiplied this row with 2 and add to the second row. I got that one, and I calculated the determinant, and really it did not change. Great. This is not a deduction, just nice to check this out. We have, yes?
I have a question. The way I look to the determinant is the area of two vectors span, right?
Yes.
So, what I'm actually thinking is that when we increased the, okay, let's see, 2 is the value of x and 1 is the value of y. Okay? Like in the row.
Yes.
This is the one vector, 2D vector. There are two vectors in 2D. And we spent the y component from 1 to 5, right?
Yes.
And the second one from 2 to 4.
Yes.
So visually, shouldn't it increase the area? But it gives the same thing.
You are talking about the case the B, I think.
Not B, I'm talking about the A and D, right? A and D are the similar vectors, but we
No. Actually, in the A, the first vector is the same. That's okay. But the second vector is different.
D is the different, right?
Yes, and if you do the multiplication, then the angle will change.
The angle changed. Yeah, okay. Their angle changed. Okay, got it.
Okay, okay,
Got it.
okay.
Now I got it.
Okay.
Exactly.
So
The
thank.
2 is paint, but 5 will change the angle as well.
Yes.
The 2 is just a multiplication.
So thank you very much. Class dismissed. This is and have a nice weekend then.
And